Good morning, researchers. This project is related to autoscaling the IoT network, Internet of the Thing network, which is having multiple clusters and fog devices, edge devices, internet users, cloud, and all. This IoT infrastructure is going to be scaled, means infrastructure may be upgraded by adding new resources due to the change in the load behavior, maybe upgraded or downgraded or whatever. It auto scales itself. Means auto scaling means automatically it can increase the infrastructure or it can downgrade the infrastructure automatically by using the technique, artificial intelligence technique, called reinforcement learning. So, in this work, we are addressing an IoT network that is having multiple clusters, and each clusters are headed by cluster head or a fog resources, and each fog resource is going to help all the clients, means edge devices, for their needs. Like computation is the need of the edge device, memory or space, or so many other qualities or the requirements of the edge devices. And edge devices have no powerful computation capacity, so they need to depend on the fog resources. And while when they depend on fog resources or a cloud resources, it is the responsibility of the edge device to solve the issues or provide the solution to the customer at reasonable time, within the reasonable time. So it means reducing the latency or a delay of response. So that is the one criteria. In the same way, it needs to reduce the cost of the user, means edge device. When you're using the edge device, when it is using the cloud or a fog resource, the cost needs to be reduced. One, the cost; another one is the time, means delay. So these are all the things so you have to be considered. So based on these aspects, as well as we do not want to put more resources in clusters to provide solution to the edge devices, because it will be more costly. So we need to auto scale the network things. So so what are the resources, like number of fog devices, and allocating the bandwidth, and RAM, providing RAM to the memory to the to the fog resources, so that upgrading CPU speed. These are all the things which comes under the resources. These resources can be upgraded or upscaled or downscaled depending on the dynamically loads coming from the edges within the clusters. So adjusting, upgrading. So yeah, you can see the diagram. So in this you can see this is a cluster. There is a diamond shape, something in block color, means block color. It is an fog resource. It is providing solution to four edge resources. They are all given in green color nodes. Devices are connected to. If some special cases, if fog device cannot solve the issues, it can upgrade. It can upload the task to the cloud, and cloud is represented in red color. And we want to reduce the dependency on the cloud. So that is the main focus, because if you depend on the cloud, there will be network connectivity issues, and so many other things will make delay. So there you can see the diagram. So there is IoT network with multiple clusters and are connected to the cloud, and each cluster is headed by the cluster resources like fog resources, and again in turn fog resources are helping the edge devices to solve their problems. Here, resource upgrading means scaling up means making more clusters or reducing the number of clusters or allocating the resources like memory, computation, speed, and these things. All called resources, so you need to upscale depending on if there is a more load in the network. Sometimes you need to reduce the resources because there is no load, so we don't want to provide unnecessarily more resources and it will be expensive. To do this we are using the technique continuous learning using reinforcement learning. So this is a deep queue network technology is used which collects the state of the network. State of the network is number of clusters, CPUs, processing speed, RAM, bandwidth. This is all resources available in the IoT network, plus what is the load which is generated during that instant. So for this load, this resource is there, is it sufficient? So like this data is collected by a reinforcement learning agent, and it suggests back whether to up upload the upgrade the network, or you need to down auto scaling, you can say. So possible actions are suggested: upscale, downscale, balance the load between the clusters, like this. So these are the possible actions: up, down, balance, or rule based scaling. So whatever it is, so it suggests this learning. And while suggesting also, it is keeping an observation on the network. So it is learning the historical data, collecting the historical data from the network. It learns and then suggests what is the better thing for the present situation. So this is like implementing an auto scaling mechanism using reinforcement learning to automatically adjust resource allocations based on workload matrix. As see, based on the workload in the IoT network, we are auto scaling, and auto scaling is done by using the mechanism called reinforcement mechanism. And it's a sophisticated approach that can optimize resource utilization, minimize the cost, and ensure the system meets the quality requirements and are varying. So these are the inputs. Workload is at clusters and number of clusters, capacity. So these are all the inputs. Network bandwidth. These are all the state. You can say state of the network is decided by like how many clusters, what is the capacity of the fog nodes at each cluster, and what is the bandwidth represent. So this is the state, and what are the actions possible: upscale, add more resources like cluster, CPU speed, core bandwidth and all. Downgrade, migrate means between the balance. Migrate means like there are multiple clusters, means multiple fog resources. One fog resource is overloaded, another fog resource may have less load, so you can coordinate between. And sometimes load and the fog resource are matching, so no need of taking any action. So this is a possible action, and based on these actions, see, this is the technique used like reward and penalty. These are the terms used in reinforcement learning. When the agent suggests some action, any of the action like upscale or downscale the networks, so means resource. So when it's suggested, based on its suggestion, system will try, and if benefits from it, then the IoT network will give the rewards. See, for example, when the action is taken from the reinforcement learning agent and it applies in the network, and if network gets benefit from that, then it rewards the agent. If it not benefits, it will punish the. So like this, this is a way of learning. We have beautiful work conducted on this simulation environment cluster. If no, see, in an environment, all the things are the cluster nodes, edge devices, and connectivity, admin. So see, agent is the core predictive auto scaling mechanism. So like this, and state is represented as like this. So this document and all the things are available on GitHub source code and all. Contact us. It's a very good research work. I auto scale the IoT network based on reinforcement learning. Is the title is the auto scale mechanical reinforcement learning. So anybody interested, they can contact or they can write review so that we will come back to you on this work. We are BPIK Technologies. Our number is mentioned in this area. Please contact if you require any work on AI and machine learning related task. Thank you. Thank you very much. Thank you very much.